All right, 2014, question 3. Take a moment and read that, and I'm going to begin. If more than 140 students are absent on the day the attendance count is taken for funding purposes, the school will lose some of its state funding. Approximately what probability that the high school will lose some state funding? Okay, so I need to know what type of distribution this is. Well, I look up and it says, oh, it's approximately normal with a mean of 120 and a standard deviation of 10.5. So my little picture indicates that I have a 120 mean. 140 is my concern. Anything above 140. And they do tell me my standard deviation is 10.5. Once again, anytime they tell me normal, I automatically write down z equals x minus mu over sigma and start plugging in to see if I have everything or what I need to find. This time I have everything, so the probability that z, because we're interested in greater than 140 minus 120 over 10.5. All right. Because we're looking for a probability, this is going to be a normal CDF with my lower bound being 140, my upper bound being infinity. My mean is 120 and my standard deviation is 10.5. And I find that I have a 0.0284 probability of losing state funding. In other words, there's about a 2.84% chance that the school will lose money. So the Principal Association suggests that instead of choosing one day, the state should choose 3 days at random. With the suggested plan, would they lose? Again, they're going to lose if it's greater than 140. Would they be more or less likely or equally likely to lose funding using the new plan? Well, because we are already dealing with a normal distribution, if we increase the sample size, we're going to be less likely because there'll be less variability. So in that case, when we draw this, we're still going to have the same picture. It should be drawn taller because we decreased the variability by choosing 3 days as opposed to 1. But we're still looking at this, but now we're looking at the distribution of the means or the average because we're talking an average of 3 days. So z equals x bar minus mu over sigma divided by the square root of n. So that's going to be the probability that z is greater than or equal to, in this case, 140 minus 120 over standard deviation of 10.5 divided by the sample size of 3 days. Now, here's what that look like in a calculator. Again, a second VARS, normal CDF. The lower bound is still 140, the upper bound is still infinity, the mean is still 120, but the standard deviation is now 10.5 divided by the 3 days, and I raise that to the half power to get my square root. So it's 10.5 divided by the square root of 3. And we find out that it is 0.00048. So it's less likely to lose funding if they go to 3 days as opposed to being 1 day, and that's due to the change in variability. A typical school week consists of the days Monday, Tuesday, Wednesday, and Friday. The principal is concerned that absences tend to be greater on Mondays and Fridays. Shocker there. And there is concern that the school will lose state funding if the attendance count on Monday occurs on Monday or Friday. If one school day is chosen at random from each of 3 typical school weeks, what's the probability that none of the days chosen is Tuesday? Well, we have Monday, Tuesday, Wednesday, Thursday, and Friday. And they say, what's the probability that none that none of the 3 days chosen is a Tuesday, Wednesday, or Thursday. Well, that means we can only choose Monday or Friday. Well, that's 2 out of 5. But how many days do we want? 3, so it'll be 2/5, 2/5, and 2/5, or just 2/5 to the third power. So 2 divided by 5 raised to the third power, and we get 0.0064. All right, the school board has decided to randomly select one day from each of 5 weeks. What is the likelihood that more than 2 of the days is either a Monday or a Friday? Well, first off, the probability of having a Monday or Friday is 2/5, which is 0.4. So the probability of having a Monday or Friday is 2/5. Or actually, I guess I should have shown that as 1/5 plus 1/5 is 2/5 equals 0.4, where that's a Monday. That's the probability of a Monday and probability of a Friday. Now, they want more than 2 of the days selected are either a Monday or Friday. So they are looking at 1, 2, 3, 4, 5 weeks, and they want the probability that more than 2. Well, that means they're looking at 3, 4, and 5. So we have a fixed number of trials, 5, making this a binomial. So it's going to be 5, choose 3, then 0.4 to the third, 1 minus 0.4 squared, plus plus 5, choose 5, 0.4 to the fifth, 0.6, or 1 minus to the 0. Now on the calculator, I'm going to subtract out what I don't want. Well, the highest value I don't want is 2. So I'm going to do a 1 minus the binom CDF of 2. So here we go. 1 minus second vars binomial CDF, trials is 5, our P is 0.4, and our X is 2. And I end up getting 0.31744. So 0.31744 is my answer. The reason it was a binomial CDF is because there was more than one value involved. Because it was more than one, it's a binomial CDF. Thank you.